In this question, we're asked to solve the following inequality. Now I'm going to start by dealing with this -3 term here. And I want to have a common denominator of x minus 2. So I'll leave the x minus 1 over x minus 2 as it is. I'll take the -3 and I'll multiply it by x minus 2 over x minus 2. So in effect, I'm actually multiplying the -3 by 1. X minus 2 over x minus 2, that cancels to be 1. So I can actually do that. Now that is greater or equal to 0. So now let me write this as a single fraction. So we've got x minus 1 minus 3 x minus 2, and that is all over x minus 2. Now I can expand this bracket here. I'll get a -3x, and I'll get a -3 times a -2, that'll give me a plus 6. And that's all over x minus 2 again. Now it's cancelling some terms in the numerator here. X minus 3x, that's -2x. -1 plus 6, that gives me a plus 5. That's over x minus 2 to be greater or equal to 0. Now looking at this inequality, what we're saying is that this inequality has to be greater or equal to 0. Now the only way it can be equal to 0 is if this numerator is equal to 0. We're assuming that x is not equal to 2, otherwise this inequality would be undefined. And for it to be greater than 0, the numerator and denominator must be positive. The other way we could do it is if the numerator is negative and the denominator is negative. And obviously 2 negatives would make a positive. So let's take each of those scenarios. So we must have -2x plus 5 must be greater or equal to 0, and x minus 2 must be positive. So these two terms would be positive, which would give me the positive I require here. This term could be equal to 0. This one obviously can't be equal to 0. Now the other option is if -2x plus 5 is less than or equal to 0, and x minus 2 must be less than 0. So if this term is negative and this term is negative, 2 negatives make a positive, give me the positive here, and obviously this term here can still be equal to 0, and this one can't be equal to 0. Going back to these two inequalities here, we get -2x is greater or equal to -5, and multiplying by -1 on both sides, we get 2x, and we need to invert this inequality. Is less than or equal to 5, so x is less than or equal to 5 over 2. And for this one, x is greater than 2. So if we look at these two here, what we've got is that x is less than or equal to 5 over 2, and x is also greater than 2. So x lies between 2 and 2.5. Now that works. Looking down here at this second one, doing a similar process, -2x is less than or equal to -5, multiplying by -1, and when we multiply by a negative, we need to invert this. So 2x is greater or equal to 5, so x is greater or equal to 5 over 2. And for this one, x is less than 2. Now here we're saying x must be greater than 2.5. Here we're saying x must be less than 2. So these two contradict each other, and therefore that can't be true. So the solution to this inequality is this one here. Now if we go ahead and graph these results, we would see the following. We can see that x is less than or equal to 5 over 2, or 2.5, and also greater than 2. X less than or equal to 5 over 2, but also greater than 2. So the full solution set is these set of values here for x. Now, if you found this video useful, please give me a thumbs up and remember to subscribe.